The first question on this homework says, which expression below is larger? Explain your reasoning in 1 to 2 sentences. So we're looking at these two expressions and we want to examine their basic structure. Like here we've got an h to the third and here we've got an h to the third. But this one is adding 5 to the h to the third and this one's adding 7 to h to the third. So definitely this one is always going to be bigger than this one, right? And then we've got h squared and h squared. But here we're adding nothing, while here we're adding 4. So when I'm looking at this, I'm thinking, well, this is always going to be bigger than this one. So larger, this one's larger times a larger number and smaller times a smaller number. So if this one's always going to be a larger times a larger and smaller times a smaller, then this one has got to be the larger one. So you come up with how you want to, I just explained that in words. You need to explain it in your own words, paraphrasing what I said or coming up with your own explanation here. But that one is larger. One other way you could have done it is you could have looked at their graphs or tables. So if you had gone to y equals and put in x to the third, and of course we have to use x's here because we don't have h, so x to the third plus 5 times x squared in y1, and then if we put x to the third plus 7 and then times x squared plus 4, we could have looked at either their graphs to compare the two graphs. That's the first graph. And the second graph, if you notice, is kind of going up even higher. So I will say that it's kind of hard to see the two graphs together. So looking at the graphs to see which one's always bigger than the other is in theory good, but sometimes you can't see the graphs. You can use the zoom fit to see if that works better. So there's the first graph. And you can see the second graph, but if you notice, the second graph is actually almost right on top of it. So again, in theory, it would be great to look at the graphs, but sometimes you just can't get the details in the graphs. So I find that actually looking at the table is easier. And if you notice here, the thing we put in y2 is always higher, always bigger. And you also want to check out things for negative numbers, because sometimes weird things happen with negative numbers too. So looking here, even still, we've got bigger right here, right? But if you notice here, something strange happens. We've got smaller. So this is the thing that happens with negative numbers, and I'm glad we checked this, because with negative numbers, sometimes when you're multiplying negative times something that's negative, you can end up with a smaller number in the end. So what we're learning from looking at this, right, is by looking at this, we realize that actually, as long as the numbers are positive, that's true. But once you get down here at -3, it's not true anymore. The second one becomes smaller. So we want to have a caveat here when h is greater than or equal to -2. That's when we saw that it was true. For -2, it was true that this was still bigger, but once it got to -3, this was smaller. So you had to put a little caveat for that.